Let's have brainstorming upon energy. Energy. What is energy? The capacity to do work is energy. Different forms of energy are found around us. They are heat, sound, wind, solar, light, chemical and mechanical energy. We are going to study mechanical energy. Mechanical energy are of two types: potential energy and kinetical energy. Energy. What is energy? Let's have brainstorming about energy. Energy. The capacity to do work is called energy. What is energy? The capacity to do work is called energy. Different form of energy exist around us. They are light, heat, sound, wind, solar, chemical and mechanical energy. Let us study mechanical energy. Mechanical energy is of two types: potential energy and kinetic energy. One more time, we are going to have brainstorming upon energy. Energy, the capacity to do work is called energy. Energy is a capacity to do work. Different form of energy are found around us. They are light energy, heat energy, sound energy, wind energy, solar energy, chemical energy and mechanical energy. We are going to study mechanical energy. Mechanical energy is of two types: potential energy and kinetic energy. Let's have brainstorming upon potential energy. What is potential energy? Potential energy, the energy possessed by the body on account of its shape, position or configuration is called as potential energy. Definition of potential energy: the energy possessed by the body, the energy which the body is having on account of, due to, on account of its shape, position or configuration is called as potential energy. Expression of potential energy. Expression of potential energy. Let a body of mass m raised to height h. If we take a body of mass m and we raise it to certain height, say h, the force acting on the body is gravitational force. Naturally, if the body is there on the surface of the earth, nearby the earth, the force acting on the body is gravitational force, which is equal to mg, Now to raise a body of mass m to certain height, work has to be done. Some work has to be done to lift a body of mass m to certain height h. And we know the formula of work. W is equal to F into S. Let a body of mass m raised to a height h. The gravitational force acting on the body is mg. And if we have to lift or raise the body to a certain height h, work has to be done. And we know the formula of work, that is W is equal to F into S. Equation 1. Here F is equal to mg and S is equal to h. So if we put F is equal to mg and S is equal to h, then equation 1 will become W is equal to mg into h, that is W is equal to mgh. Equation 2. My dear student, in order to raise a body of mass m to a height of h, some work has to be done, and this work is mgh. Work is done to raise the body to certain height h. This work done is stored in the body in the form of energy. The work done to raise a body of mass m to height h is stored in the body in the form of energy. The work done to raise a body of mass m to a height h, okay, certain work is done. This work is stored in the body in the form of energy. In the form of energy. The work done to raise a body of mass m to height h is stored in the body in the form of energy. This energy possessed by a body is on account of its position, and as this energy is possessed by a body on the account of its position, this energy is called as potential energy. W is equal to mgh. Equation 2. Here work is equal to potential energy. The work is equal to what? Potential energy. So in place of W we can write potential energy. And the potential energy is equal to mgh. So the expression for potential energy is equal to mgh. The capacity to do work is called energy. Different forms of energy are found around us. They are heat, light, sound, wind, solar, chemical energy and mechanical energy. We are going to study mechanical energy. Mechanical energy is of two types: potential energy and kinetic energy. Let's have brainstorming upon potential energy. The energy possessed by a body on the account of its shape, position or configuration is called as potential energy. Derivation of potential energy. Let a body of mass m raised to a height h the force active on the body is gravitational force of the earth, and which will be equal to mg. When we raise a body to certain height, work has to be done. We know the formula of work. W is equal to F into S. W is equal to force is mg. S is displacement, and the displacement is height. So work will be equal to mgh. Now this work will be stored in the body in the form of energy. This work is stored in the form of energy, and this energy possessed by a body is on account of its position at height h. Therefore, this energy is called as potential energy. So, W is equal to mgh. In place of W, we wrote potential energy, and finally we are able to derive the expression of potential energy. So potential energy is equal to mgh. Now we will consider kinetic energy. Kinetic energy, the energy possessed by the body on account of its motion is called as kinetic energy. Let's have brainstorming upon kinetic energy. The energy possessed by a body on account of its motion is called kinetic energy. The energy possessed by a body on account of its motion is called as kinetic energy. The kinetic energy is related to motion. Let's study the expression of kinetic energy according to Newton's second law of motion. expression of kinetic energy according to Newton's second law of motion. Let M be the mass of body, U be the initial velocity, V be the final velocity, A be the acceleration produced in time t, S be the displacement of body. Let M be the mass of the body, U be the initial velocity of the body, V be the final velocity of the body, A be the acceleration produced in the body in time t, S be the displacement of the body. F is equal to ma. According to Newton's second law of motion. Here the body is in motion. So let's consider kinematical equations. So we have three equations of motion. V is equal to U plus AT. S is equal to ut plus half at square. V square is equal to u square plus twice as. Let's consider equation 3. S is equal to ut plus half at square. Here u is equal to 0 as the body is in motion. Therefore, this equation will become S is equal to 0 into t plus half at square. S is equal to 0 into t is 0, half at square. Equation 5. Expression for kinetic energy according to Newton's second law of motion. Let m be the mass of body, u be the initial velocity, v be the final velocity, a be the acceleration produced in time t, and s be displacement of body. We know F is equal to ma according to Newton's second law of motion. Here the body is in motion, so let us consider kinematical equation. We have three kinematical equations. V is equal to u plus at, S is equal to ut plus half at square, V square is equal to u square plus twice as. We will consider equation 3. Let us consider equation 3. X is equal to ut plus half at square. We know that here u is equal to 0 because initial velocity is 0 because the body is in motion. So in place of u we can put 0. So s is equal to 0 into t is 0. So s is equal to half at square. Equation 5. We know that W is equal to F into S. Equation 6. F is equal to ma from equation 1 and S is equal to half AT square from equation 5. This value we have got. So we will put the value of F and X in equation 6. So the equation 6 will become W is equal to F into S. W is equal to M A into S is what? Half A T square. We'll arrange this equation. W is equal to half into M into A into A into T square. W is equal to half M A into A is equal to A square into T square. Again we can arrange this equation. W is equal to half M AT whole square. Equation 7. Now let us consider equation 2. Equation 2 is V is equal to U plus AT. Here U is equal to 0. So we will put the value of, in place of U we will put 0. V is equal to 0 plus 80. V is equal to 80. Squaring on both the side. V square is equal to 80 square. Seven. We got equation 8. Put V square is equal to 80 square in equation 7. Equation 7 is what? W is equal to half M 80 square. So the equation will become W is equal to half M in place of 80 square will put V square. Equation 9. Now here work is done. This work will be stored in the body in the form of energy. This energy stored in the body is on account of its motion. Therefore, the energy is called as kinetic energy. So, in place of W, we can write kinetic energy. And the expression for kinetic energy will be half mv square. The work done is stored in the body in the form of energy. This energy stored in the body is on account of its motion. And as it is on the account of its motion, the energy is called as kinetic energy. Therefore, work done is equal to kinetic energy. So, in place of W, we can write kinetic energy. So, this is kinetic energy half mv square. We have derived kinetic energy according to Newton's second law of motion. Let's derive expression of kinetic energy from kinematical equations. Derivation of expression of kinetic energy from kinematical equation. Let m be the mass of body, u be the initial velocity, v be the final velocity, a be the acceleration produced in time t, s be the displacement of the body. We are studying derivation of expression of kinetic energy from kinematical equation. Let m be the mass of the body, let u be the initial velocity, v be the final velocity, a be the acceleration produced in time t, s be the displacement of the body. We know three kinematical equations that are we have three kinematical equations. 1, 2, 3. V is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus twice as. We will consider equation 3. Equation 3 is v square is equal to u square plus twice as. V square minus u square, we will take other side of the equation, is equal to twice as. V square minus u square, I will take twice a on the other side of the equation, multiplication will go to denominator, is equal to s. Therefore, s is equal to v square minus u square upon twice a. Equation 4. According to Newton's second law of motion, we can write F is equal to ma. F is equal to ma. We also know W is equal to F into S. Equation 6. Now F is equal to ma and from equation 5, and S is equal to v square minus u square upon twice a. We can put in equation 6. So equation 6 will become W is equal to F into S. W is equal to ma into v square minus u square upon twice a. Here a will get cancelled. W is equal to half m v square minus u square. But u is equal to 0, therefore u square will also be equal to 0. We'll put it in equation. W is equal to half m v square minus 0 square. W is equal to half m v square. Now here, the work done is again stored into the body. It is stored in the form of energy. The work stored in the form of energy is on account of its motion, and therefore the energy is called as kinetic energy. This work done is stored in the body in the form of energy. This energy stored in the body is on account of its motion, because the body is in motion and we are deriving the expression from the kinematical equation. This energy stored in the body is on account of its motion, and so this energy is what? Kinetic energy. Therefore work is equal to kinetic energy. So in place of W, W is equal to kinetic energy, so we can write this is the expression of kinetic energy. Kinetic energy is equal to half mv square, which we have derived from kinematical equation. Law of conservation of energy. Let's study law of conservation of energy. Law of conservation of energy. According to law of conservation of energy, energy can neither be created nor destroyed. It can be changed from one form to another. The total amount of energy in the universe always remain constant. From this law of conservation of momentum, we can say that we cannot create energy nor we can destroy energy. Energy is converted from one form to another form, and the total amount of energy in the universe always remain constant. Let's have brainstorming upon law of conservation of energy. According to law of conservation of energy, energy can neither be created nor destroyed. It means that we cannot create energy, we cannot destroy energy. It can be converted from one form to another form. And the total amount of energy in the universe always remain constant. Now, my dear student, in order to study this law of conservation of energy, we have to study free fall. But what is free fall? Let's have brainstorming upon free fall. What is free fall? When the body falls under the influence of Earth's gravitational force alone, then the body is said to have free fall. Means when the body is falling freely, only gravitational force is acting upon the body. No other force is acting upon the body. And in this situation, we can say that the body is having free fall. In order to study law of conservation of energy, we have to study free fall. What is free fall? When the body falls under the influence of Earth's gravitational force alone, then the body is said to have free fall. Let a body of mass m released from the height h have a free fall. We will consider potential energy and kinetic energy at different height in order to study law of conservation of energy. Let a body of mass m released from the height h have a free fall, and in order to study law of conservation of energy, we will consider potential energy and kinetic energy at different height. Let a body of mass m release from point A. Then the body will move at point B, and finally the body will come at point C, which is on the ground. As the body is released from height h, so from A to the ground level, the height of the body is h. Let the body travel the distance of x between A and B. Now the body is at a height h minus x from the ground at point B. Now we will study kinetic energy and potential energy at point A, B, C in order to study law of conservation of energy. At point A, H is the height of the body from the ground. V is equal to 0, therefore V square also 0. Reason? Because the body is at rest at point A. Now potential energy. Potential energy at point A is equal to mgh. Kinetic energy. Kinetic energy is equal to half mv square. But v square is equal to 0. Therefore, the equation becomes kinetic energy is equal to half m into 0 square. Therefore, kinetic energy is equal to 0. The total energy at point A is equal to total energy at point A is equal to potential energy plus kinetic. What is potential energy? Potential energy is mgh. Kinetic energy is 0. Therefore, total energy at point A is equal to mgh. Equation 1. Now we are going to study potential energy and kinetic energy of a body which is falling free fall or which is having a free fall at different height A, B, C. Let's study first at point A. At point A, the height of the body from the ground is h. Here V is equal to 0 because the body is at rest and therefore V will be is equal to 0. So V square will also be equal to 0. Potential energy at point A is equal to mgh. Kinetic energy is equal to half mv square. But V square is equal to 0. Put V square is equal to 0 in equation. The equation becomes kinetic energy is equal to half mv square. Therefore, kinetic energy is equal to 0. Potential energy is equal to mgh. Total energy is equal to potential energy plus kinetic energy. Total energy is equal to mgh plus 0. So total energy at point A is equal to mgh. Equation 1. Now let's study potential energy and kinetic energy at point B. At point B. The height of the body from the ground is h minus x. We don't know. As the body is in motion, we will take help of as the body is in motion, we will take help of kinematical equation, that is V square is equal to U square plus twice AS. Here U is equal to 0 because the body is in motion. A will be A is equal to G as the body is falling vertically downwards towards the surface of the earth. Acceleration due to gravity, acceleration will change into acceleration due to gravity. Here x displacement is equal to x as shown in figure. We are going to consider potential energy and kinetic energy of a body at point B. At point B, the body is in motion, so we will take use of kinematical equation, that is V square is equal to U square plus twice AS. Now here, as the body is in motion, so initial velocity will be 0. Acceleration will get converted into acceleration due to gravity because the body is falling towards the surface of the earth. Second, S displacement. As taken in our example, the distance between A and B is x, so displacement is x. Now we will put the values. V square is equal to 0 plus what is the equation? V square is equal to U square plus twice AS. V square is equal to 0 square plus twice GX. V square is equal to twice GX. At point B, height of the body is h minus x and V square is equal to twice gx. Now let's study potential energy and kinetic energy at point B. potential energy is equal to mgh. But h is equal to h minus x. Therefore, potential energy is equal to mg. In place of h, we will put what? H minus x. Therefore, potential energy is equal to mgh minus mgx. Potential energy is equal to mgh minus mgx. mgh minus mgx. Kinetic energy. Kinetic energy is equal to half mv square. But v square is equal to twice gx. We'll put twice gx in place of v square. We will get kinetic energy is equal to half m into twice gx. Cut. Kinetic energy is equal to mgx. My dear student, at point B, we got potential energy, we got kinetic energy. Now, we will try to find out total energy. Potential energy is mgh minus mgx plus kinetic energy is mgx. Plus mgx minus mgx will be cancelled and you will get at point B. equation 2. In equation 1, total energy we got mgh. Equation 2, total energy we have got mgh. Now we will study potential energy and kinetic energy at point C. At point C, the body is at the surface of the earth. X is equal to 0. The body is at the surface of the earth. V square we don't know. Again we will take the use of kinematical equation, that is V square is equal to U square plus twice A S. V square is equal to, as the body is in motion, U will be 0 plus 2. Acceleration will change into acceleration due to gravity, and this will become G, and the displacement from A to C is H. So we will get here H. So V square is equal to twice GH. Potential energy at point C is equal to mgh, but h is equal to 0. So potential energy is equal to 0. Kinetic energy is equal to half mv square. Kinetic energy is equal to half m into v square is twice g h. To cut. Kinetic energy is equal to mgh. So at point C, total energy is equal to mgh. H is equal to 0 because the body is on the surface of the ground and H is equal to 0. As the body is moving, we will consider the kinematical equation V square is equal to U square plus twice AS and V square is equal to 0 plus twice GH and V square we have got twice GH. Potential energy is equal to mgh but height is 0, so potential energy will be 0. Kinetic energy is half mv square. The value of v square is equal to twice gh, we have find it out. So kinetic energy will be mgh. Total energy is equal to potential energy plus kinetic energy. Potential energy is 0 and kinetic energy is mgh and total energy is what? mgh. From equation 1, 2, 3. Total energy at point A is mgh, total energy at point B is mgh and total energy at point C is mgh. From equation 1, 2 and 3 we can say that total energy at each point of motion of a body in free fall is constant. From all the three equations we have seen that it is constant. When the body is released from certain height, potential energy is mgh. It goes on decreasing. It goes on decreasing and kinetic energy goes on increasing. So when the body is falling from point A, potential energy goes on decreasing. On the other hand, kinetic energy goes on increasing. the potential energy is converted to kinetic energy when the body strikes the ground. This potential energy is converted into kinetic energy when the body strikes the ground at point C, which is means potential energy get converted into kinetic energy, which is equal to potential, which is equal to potential energy at height h. From equation 1, 2 and 3 we can say that the total energy at each point of motion of a body in a free fall is constant. When the body is released from point A at a height x, the potential energy goes on decreasing and kinetic energy goes on increasing. Potential energy decreasing and kinetic energy goes on increasing. The potential energy is converted to kinetic energy when the body strikes the ground. The entire potential energy is converted into kinetic energy when the body is reaching the ground. So this kinetic energy, which is this kinetic energy, which is equal to potential energy, at point A, which is at height h. From this example, we have studied that in a free fall, the total energy always remains constant, and this helps us to understand the law of conservation of energy. Energy can neither be created nor destroyed. It can change from one form to another form, and the total amount of energy in the universe always remain constant. Thank you.